So many of the concepts that actually I shouldn't even say it that way. All of the concepts that we study in physics will line up with an existing mathematical model. So even though this line doesn't look straight, like if I drew it, it would be all jaggedy. Conceptually, the data here looks like it would conform to a straight line, so we draw a line of best fit. There will be other lines we draw where conceptually it's obviously curved. And so we're going to draw curves of best fit. I'm going to show you the tool that we're going to use for that today. It's called a French curve. And so if it looks like it should be a straight line, draw the straight line. If it looks like it should be curved, draw a smooth curve. We're not connecting dots ever in this class. So we had our line of best fit here. And again, I think my video went through it. The wires, even though like you're plotting data presumably no current should mean no voltage. But my line doesn't go through 0, 0. It wasn't a data point, so I didn't include it as part of my line of best fit. So this kind of represents an error here. And then the slope calculation was, I think, the first chunk of the homework that I gave you to do. Your graph needs to include all of the pieces that you've got here. You've got a title. You've got labels on both your axes. You want to pick good scales. So let's flip ahead. And Kai, you wanted to know, so this was the page I gave you first for homework, determine the slopes and the equations of the lines. So slope for A is this line here. Going down to the right, it's negative. Rise over run was negative 4/3. The slope for B is undefined because there is no run. And the equation for a vertical line is always, so if you look at the vertical line, it goes through where x is equal to 6. X is only ever equal to 6, and it doesn't matter what y is. When you have a vertical line, or even a vertical or a horizontal line, your equation is going to be based exclusively off of whatever variable is locked. So in this one, x is locked to 6. Doesn't matter what y is. X is 6 everywhere. And so that's the equation that you would then give. It's something that you would have looked at once way back in grade 9. And I know you did, Kai, because you were in my pre-diploma 9 class. But you probably haven't seen it since. So that's what that would look like. Graph C has no slope because it has no rise. It's just a run. Y is equal to 1 because that's the y-intercept. And then D, the slope is 1/3, and it's y equals mx plus b. The y-intercept was negative 4, so it's going to be y equals 1/3 x minus 4. Is there anything there anyone would like me to explain in more detail? Okay, flip the page. Then I went through the video, would have gone through this page, graphing data. I had a discussion here about choosing scales that are good. Is there any questions about scales? Choosing your own scale? It really just comes with practice. I can tell you again and again and again what kinds of numbers to do, but until you actually get in there and start doing it yourself, it's going to be an uncomfortable process. You're going to second guess yourself. The person beside you might be drawing something different. Might be your best friend sitting beside you and they chose a different scale. That's fine. Their scale can look different than your scale, and you're still going to produce totally acceptable graphs. And that drives a lot of students crazy. Sorry, it's going to bother you. You want to pick a scale that uses at least half your graph. And then there was an explanation here on the best curve or best line of best fit. I did an example. I think it was just one example for you. Or did I do 2 examples? I had 1 example for you, and then there was 3 I wanted you to play with. So, the ones I wanted you to play with were, I did tweak the video. Did she explain that? The video said do these questions, and then I actually want her to change that. She explained it. Okay, good. So, here is what my example 2 would have looked like. I wanted to use at least half the graph. I graphed, what you call it, B versus A or A versus B. Generally speaking, data is usually going to be given to you like this, X and Y. The independent variable on the left, the dependent on the right. Not always, but usually. So this is what my graph looked like. I needed to go up to 12, and there weren't 12 lines here, so I didn't choose 1 to be my scale. I went up by 2s, because you want to use at least half your graph. Yeah, Kai?
Why wouldn't you make A go by 3s?
3s are always a bad idea.
But the graph,
I know. But as much as humanly possible, I avoid 3s. Because even like choosing to go up by 2 still is going to hit that data point, that data point, that data point. And 3 is the halfway point for so many of these. As a general rule, I will avoid 3s at all costs. Even on something like this where your data looks like 3s are good values, don't get into the habit of picking crappy scales. I would still do 2s. That said, you're right. It does go up by 3, and if you did 3, I wouldn't necessarily mark it wrong. But if I gave you, like, if I had, like, I don't know, if I'd given you data points in here that you then had to approximate, I would tell you to pick a better scale. So that's 2. I'm going to redo 3A for reasons that I'll show you here in a second. They gave you this data here, and I said it's almost always going to be like this. It'll almost always be X then Y. But did I talk about variables that were independent? I don't remember. Given this data, what's the independent variable going to be? What should it be? Time. 98% of the time is independent. It's very rare that time is dependent. I could concoct an example where it was, but 98% of the time is going to be on your x-axis, and then whatever else it is going to be on your y-axis. So time goes down here, distance goes up here. This is the data that we're working with. And now you've actually got a few options for scales here. How did you guys scale this? Hands up. What? Give me an example of what you did. Brad.
I used by 2 for the seconds for the time, so it's 2.6.
Okay, before you say anything else, did anyone use a different scale for time than 2s? Cool. So we all use 2s. I also used 2s. Brad, keep going. What'd you use for y? Okay. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and you just kind of estimated, you tweaked it a little bit on the up? Okay. Did anyone use a different scale for distance than 10s? What'd you use? 5, 0? 1, 5. You could use 15s. 15s are dicey. For the same reason I wouldn't use 3, I wouldn't use any multiple of 3. 15, I'd have to take a look. 15 you could do. There's a better one, I would argue, Kai. We want to stay, for the same reason that I would want to avoid 15, I want to avoid 12. Avoiding multiples of 3 at all costs is going to make your life so much easier when you're graphing these things. You could. Did anyone use, so Brad used 10s, we have 15s, we got 12s. What else did we do? What did you go up by? No, a minute. Okay. Nobody picked anything else. Mary, what'd you pick? You went up by 10s. Ezra. Okay, everyone else went up by 10s. Okay. When I did this the first time, I went up by 20s. So 20, 40, 60, 80, 100, 120. It still gives me about half the graph. 20, 40, 60, 80, 100, 120. Because, well, and then even then, like we can plot relatively easily. If I want 30, 30 is going to be about halfway, and 32 is going to be just slightly above that. 38 is going to be, well, 3 is halfway between 2 and 4. And then 38 is going to be almost 40. 5 and 50. It's going to be right in the middle of that square. 7 and 63 is going to be right there. 86 and 11. It's going to be just above 80. About a quarter of the way up. And then 104 and 14 is going to be like right there. Brad, using your scale, what was your slope?
Well, I didn't calculate the slope. I just wrote down the.
Oh, did I not ask you to do that? Shoot, you just graphed it. Dang.
I can do that right now.
Okay, so here's some of the notes that I made before. So some other options. So we got some other scale options here. You can make them work. You guys, so the 12s that I heard, the 15s, Kai and Marcos use 12 and 15. You can make them work. As a general rule, so Brad, anyone who picked 10 as their scale, if the data goes beyond the graph, I would say get other graph paper if that's the scale you want to use, or there's a symbol you can actually throw in to make your life easier. So this is the same data. Example 3b is the same data. I would graph D and I would graph T. If I wanted to use, I'm going to go up by 2s here, 2, 4, 6, 8, 10, 12, 14, 16, 18. And then if I wanted to go up by 10s, seeing how nothing here drops below 32, there's a symbol I would add to the graph so that when I went up by 10s, I wouldn't exceed the graph that was here. And the symbol looks like this. It goes out, it goes over, it looks like Harry Potter's forehead. Looks like that. And what that symbol means is you can still start here at the bottom at 0. That symbol means I have nothing between 0 and my starting value here. So at this point, what I did, is I drew that little symbol in there. I called this 30, and then I went up by 10s at that point. You could even call that 20, just to give you one below, because if you did that by 20s, you'd go 20, 30, 40, 50, 60, 70, 80, 90. That would be 100. That would be 110, and you'd still get all your data in there. So if you're gonna, if your data doesn't require you to go all the way down to 0, this point should always be 0. Your scale needs to be the thing that you go up by uniformly every time. Throw that symbol in there, and then you can start this next value, whatever you want. And then as long as you're consistent, that's how I would do that. And that's how I would encourage you guys to do the same. Comments, questions, concerns here. Okay. Then, the last one would have been this additional questions one here. It would have looked like this. I would have done probably my time scales by 2 again. 2, 4, 6, 8, 10, 12, 14, 16. And then I would go by 1s on this guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd get a graph that would go through 0, 0. It would go through 2 and 1, and then time value of 3 and a distance of 2. A time value of 6 and a distance of 3. A time value of 10 and a distance of 5. a time value of 14 and a distance of 7. And then you draw a line of best fit through there. This one is a little bit weird, but that's okay. I'd still draw my line of best fit through that. Do not connect dots, as a general rule. Okay, we're going to be doing a bunch of graphing all semester. Lots of our labs are going to require you to graph the relationship, and it's going to be on a bunch of tests. It'll be on your final exam. So lots of graph practice is what I want to spend the next couple days doing. And I'm going to show you some tools for doing this. So today is largely going to be continued practice, and then I'll float around and help out. What I want you to do today, and I didn't want to assign it yesterday because it was really a possibility that we just, didn't do it. So here's what I want you to do. Today is Thursday, not Friday. Okay. Yeah, cool. So what I've done here is I've got these questions in here. There are 4 of them. I've got the first chunk here is more of, it's just a reiteration of explaining everything that we've done. My expectations for the graphs, identifying what's independent, identifying what's dependent, good scales, labeling things, all the stuff that was in that video is re-explained again right here. That's what this is. Then I got 4 questions. Some of them, they will all have you, most of them will have you graph multiple things. So this one is a car traveling down a road. It gives you a whole set of data. It wants you to graph original speed versus reaction distance, so these 2 columns. Analyze the graph to determine the equation. And then it wants the graph of the original speed versus the total distance. And then it wants you to describe the relationship or the difference between the 2 graphs. Question 1, do on 2 separate graphs. Don't throw your data on the same one. For question 2, you're plotting one graph. You're answering a bunch of questions about that graph. Question 3, one graph. You're answering a bunch of questions about that graph. I'm just going to put an asterisk next to this one. When you get there, let me know. Before you draw any lines, let me know. And then question 4 will have you draw 2 graphs as well. One of them is, so it's for a pendulum, one is the period versus the length, and one of them is the period versus the square root of the length. You have to go through and you have to calculate all of this. And you're going to graph them separately. This is 2 separate graphs. So what you're doing is 2, 4, 6 graphs today. I have included in this booklet 1, 2, 3, 4, 5, 6 pieces of graph paper. We graph in pencil. If you screw up and you don't want to erase and you want a different one, I have more of this stuff printed, let me know. I don't care if you choose to landscape these things or portrait these things. For lots of the data, if it works easier to use at least half the paper, landscape is a great way to do it. I'll let you decide how you want to play with that, the scale you choose to use and all that jazz. I'll walk around and help where needed. And again, before you draw any lines on number 3, let me know. I'm going to show you a new tool that we can use to graph things like that. Okay, so you've got your task on your mark and set giver. So you're going to be graphing these tomorrow. For question 3, okay, Kai, give me a second. 1 second. Question 3, you're going to do A, plot the distance versus time graph. I want you to do B, but do not connect the dots. Kai and Kale, pay attention to this, please. I'll give you a hint. 3 is not going to be linear. On Monday, I will go through how to make it a curve we can use. And then question 4 you can do, but question 4, A, don't do B, do not do B. We'll come back to B. And then question A on number 4, do not connect. In fact, you know what I'll say? When you get to number 4, only do A, don't connect the dots. Do C and D. We'll come back and look at B, E, and F on Monday. There's some stuff I want to show you in there. But like I said, I can hardly see you right now. Everything's so cloudy. And I feel like death warmed up. So that's going to be the plan. Tomorrow, and it's a short block tomorrow. It's SLO, so you only have an hour. So which I think is giving you time today and time tomorrow to graph. And I'll take up any questions you have on Monday. I don't expect lines of best fit to be something you're super comfortable with yet. It'll take a ton of practice. We're doing lots of this stuff. And then Monday, if you have a computer, bring your computer to class on Monday. We're going to start up. We've done a bunch of stuff by hand. I'm going to start showing you how to use 3 programs to do this. Excel, Sheets, and a program called Desmos. If you have laptops, bring them on Monday. Yes? Yes. It should be intensity, distance versus intensity. And when you guys are doing, yeah, you're leaving. Yeah, we'll leave there. Thank you. Okay, have a good day, guys. We'll see you Monday, because I'm definitely going to be away tomorrow. If you borrowed a ruler, please put it up on the table up at the front. Have a good day. We'll see you later. Sorry? Okay. Hold on. Don't go anywhere. Don't leave until I actually do it. Joshin. Got you. Easy. Fixed. Done. No worries. Okay. Holy crap. Hey. Close. You. And you. And stop you.